Hi, my name is Lillian Petersen, and I created a model to predict crop yields in every country in Africa 3 to 4 months before the harvest using satellite imagery. Developing countries often have poor monitoring and reporting of weather and crop health, leading to slow responses to droughts and food shortages. For example, there was a severe drought in Ethiopia in 2015 and 2016, and aid organizations were unprepared. When I read about this food shortage on the news, I became determined to create a model to monitor droughts as they develop. First, I conducted a validation in Illinois. I retrieved 600,000 daily images from the Descartes Labs satellite platform, or about 12 terabytes of raw data. I then filtered out clouds and computed the monthly NDVI, averages, climatologies, and anomalies for every pixel. NDVI is a measure of crop health, computed from the different bands of the electromagnetic spectrum. Basically, if a crop is greener, it has a higher NDVI. I then computed correlations between the corn yield in Illinois, shown here in green, and the NDVI anomaly, shown in blue. The correlation was very high at 0.9. The NDVI was much lower in a drought year and much higher in a wet year. I then computed correlations between the NDVI anomaly and the corn yield for every county and every year in Illinois. These had correlations of up to 0.87, with p-values less than 10 to the negative 6. These high correlations in Illinois show my model has good predictability of crop yields. I then applied my model to Africa. I computed the monthly NDVI average and then found correlations between the month with the highest NDVI average and the crop production. Ethiopia had very high NDVI anomalies in a wet year and very low NDVI anomalies in the drought year of 2015. I then predicted future crop production for every country in Africa for the 2018 season, and later compared my predictions to reported crop production. My predictions were quite accurate. 40% of my predictions had less than a 5% error. I then further analyzed these predictions based on the satellite index, the crop, and the country, and all of this analysis can be found in my 2018 peer-reviewed paper in remote sensing. I compared my model to other models that predict crop health. Current early warning systems of crop yields in Africa are actually run on extensive budgets and cannot be easily scaled across large areas. What's more, these current early warning systems are severely hindered during COVID-19 because they rely on observers on the ground to report on crop conditions. Now more than ever before, it is critical to have a system that can predict crop yields completely remotely. During COVID-19, it's important to monitor whether farmers have sufficient access to seeds, fertilizer, pesticides, and whether the locust swarms are harming crops. It is important to know whether the repercussions of COVID-19 are leading to a potential food crisis brewing in the future. This information could help aid organizations respond faster and further food security. That is why I just updated my 2020 crop predictions earlier this week and was invited to share these predictions with top researchers at the International Food Policy Research Institute just this Tuesday.